And the more you look at the stars, the more you discover. We'll explain how a powerful new space telescope is expanding our view of the universe.
NASA's new James Webb Space Telescope has revealed that there were 10 times more galaxies like our own Milky Way in the early universe than previously thought. Emily Brown has this report.
The universe, 13.8 billion years old, captured here by the world's most powerful telescope. After entering service earlier this month, the James Webb Telescope has found there were 10 times more galaxies just like our own Milky Way than previously thought.
Many of them are actually almost normal looking in some ways, like a disk galaxy, like our own Milky Way is a disk galaxy, a rotating system which is elongated into a kind of a symmetrical disk shape, which is surprising because we thought that those kind of galaxies did not exist, but now we're finding them in great abundance quite early in the universe.
And the discovery has been made possible by collecting invisible infrared data. The teams studying the results describe it as revolutionary.
It's really one of the most amazing telescopes that astronomers have ever built, and it's maybe comparable to something like the first telescope that Galileo used to just look at stuff for the first time with the telescope.
More images will be captured over the coming months, possibly leading to even greater discoveries. Emily Brown, BBC News.
Well, I've been speaking to another astronomer, Professor Roger Windhorst, about what the discovery means for our understanding now of the universe.
It is further back in time. Therefore, the universe was smaller and all the light that we received has moved from the optical into the infrared. So we really need Webb to see these very early objects.
When you say further back in time, how much further? What sort of distance away?
Webb will make us look well within the first billion years, probably to within, we think, the first 300 million years. We're not quite there yet. We still got some more observations to do before we looked at that far back in time. Hubble sort of stops the first 500-600 million years after the beginning. A curtain falls. It can see no further. It cannot see further in the red than those distances. But Webb can.
What are we learning so far? Or is it too early to say? At the moment it's just images, but these will need to be sort of pored over, will they, and studied for several months?
It will take us a while to analyze it. We've only had the images for less than a week. But we will see the first galaxies and perhaps even the first stars as they're forming. We need some help for that. And here's where Einstein comes to the rescue. We use the foreground massive object called clusters of galaxies that will magnify the light. It will turn it into these beautiful arc-looking things. And in that process, it gets magnified to beyond the limit that we can detect. We could not originally see it, but with the help of foreground gravity, we can see these objects.